Alright, so today we'll just be factoring special binomials. That's what those two problems were called. So when we're factoring special binomials, when a binomial, and how many terms are in a binomial? 2, has subtraction in it. So subtraction, if I get this spell. When a binomial has subtraction and both terms are perfect squares, it is called the difference of, so on those problems, how many terms do we have in there?
2.
2. The difference of 2 squares. Alright, so just right below that we just have some examples of differences of 2 squares. So that first one, x squared minus 9, is x squared a perfect square? So what times what equals x squared? X. What times what equals 9? 3, and then there's a subtraction sign, so it's a square minus a square, or a difference of 2 squares. So then, next one, 4x squared minus 25. What times itself would be 4x squared? 2x. 2 times 2 is 4, x times x is x squared, then 5 times 5 is 25, and so on. So, just in this blank one, someone give me an example of a perfect square. Just any random one. Ricky?
10 times 10 is 100.
So 100, okay. We always have to have a minus for difference of 2 squares. Someone else give me another one. Is 6 a perfect square?
No.
3 times 16.
Michaela?
16. Oh, that's right.
Alright. 16, I'm just going to put x squared in there.
Could it be the other way around? Like how they do the square first?
Yeah, we could have the 16x squared first, but we still have to have that minus sign in there. So it would have to be 16x squared minus 1.
Wait, could it be 100x squared minus 16?
It sure could.
So just any perfect.
Any perfect square minus any other perfect square.
And why does it have to be like x squared first? Does it like instead of like 100 minus 16?
Oh, what's 100 minus 16?
Not
84.
Oh,
So we have x squares in there just so we can represent any other number that it
We
could be.
can't have like terms.
That's why.
Oh, okay.
Because 100
Then
minus.
they could be combined, but we not have our binomial anymore.
I see.
Alright, so when we want to factor the difference of 2 squares, we have to find the square root of each term. So we have to find the square root of the first one and the second one. When we do that, we're going to have 2 binomial answers. Each of those factors is going to start with the square root of the first term. So whatever our first term is in our difference of 2 squares, our 2 binomial factors are going to start with the square root of that. And if they're going to start with the square root of the first term, what do you think it's going to end with?
second term.
For last.
The square root of the second term. And then last thing, one factor will have,
X squared.
no, so in our 2 answers here, what kind of signs do they have? Addition and subtraction. One's going to have addition, the other one will have subtraction. Alright, so we're just going to do some practice problems now. This first one, number 1, x squared minus 9. Is that a difference of 2 squares?
Yes.
Is x squared a perfect square? Is 9. They're being subtracted, so yep, we can say that is. What's the square root of x squared? Carly?
X.
X, right? What's the square root of 9? Blaine? 3. So we found the square root of our first term, found the square root of our second term. So each of our binomial factors are going to start with, you're going to start with x, they're going to end with 3. One's going to have subtraction, one's going to have addition. Doesn't matter which order we put them in.
Is that all we have to show?
Hmm?
Is that all we have to show?
Yeah,
Yes.
What the heck?
this is really easy, isn't it?
That's
Yeah.
the whole lesson.
Pretty much, yeah.
Nice.
So, number 2. Find the square root of the first and second term. What's the square root of the first term?
X.
X, so we have square root of x squared equals x. Square root of the second one, square root of 64 is 8. So our final factored answer should read
I
what?
have a question.
Yes, Carly?
Would it have to be negative 8?
Nope, all we're worried about is just the
Just the
number.
numbers?
Yep. Riley?
It would be x plus 8 and x minus 8.
X plus 8, x minus 8. Because they both start with the square root of the first term, they both end with the square root of the second term.
Holy, easy today.
One has addition, one has subtraction. All right. So moving on to numbers 3 and 4. Before we start, what are some differences that you see between just number 3 and 1?
Number 3 has a value for x squared.
Right, number 3 has a value for a that isn't 1. So number 1 and 2, a was just 1. 3 and 4, a isn't 1. Yes, Rich?
Does this mean we'll have to factor quadruple?
Nope. So we're just going to do the same thing. Square root of the first term,
2x.
2x. 2x times 2x equals 4x squared. Square root of 25, 5. So they're going to start with what and end with what?
2x and
2x and 5, right. Yes, Carly?
How would you check that? If you had to?
If you had to check it, you could just FOIL this out or rectangle method it. If you get what you started with, then you're good.
Do we have to do check on this too?
Yes, Blaine?
Just multiply them.
Yep, you can just multiply them together, and if you get the same thing that we started with, then you know you're good. All right, you guys do number 4 by yourselves. Pretty free to buzz down in 1 minute.
Yay.
All right. So, square root of our first and second term, what's the square root of 9x squared?
3x.
3x. The square root of 16?
4.
4, so they're both going to start with 3x. They're both going to end with 4. And one has subtraction, the other has addition. Again, doesn't matter which order they're in? No, it doesn't, because either way, when we multiply it out, you should always get the same answer. All right, moving right along, we can go to the backside now. Number 5 and 6, you guys do that. You guys do those 2 by yourself.
Oh.
You guys do that?
I'm not sure, but
Square root. I mean, like, because they give 3 6, they do like negative 6 is 6. Oh, like, could be.
What's the square root of 36?
Square root of 36 is 6.
Right. Square root of x squared.
X. So it's just 6 x. There's a negative sign.
Just
All
for
we're, yeah, all we're worried about is the numbers. It's first squared, and then first squared, and then we do the first squared. It's
Okay, for number 5, never mind.
There you go.
Would you put the X's first or second?
Doesn't matter.
Doesn't matter.
What were you trying to say? You said something.
Yeah, it was 36 x squared.
Right.
Yay, yippee.
That's my class.
That's right. Right. Yes, Isaiah?
What if it's not a perfect square?
Let's find out. All right, number 5, square root our first and second term. Square root of 1 is? 1. Square root of 36x squared is? 6x. So our final answer is?
1 minus 6x
1 minus 6x,
and 1 plus 6x.
1 plus 6x. It can be in either order.
Be careful about that though, when you say that. What can be in either order?
How'd you get
The binomial.
The parentheses thingy, like the multiplication.
Give me an example of another way this could be written. Okay, Christian,
1 plus 6x
that?
times 1 minus 6x.
okay? Are there any other ways?
Yes.
And I'm not talking about not cleaned up, okay? Blaine, what's another way you think it could be written?
6x minus 1 times 6x plus 1.
Would that multiply back to 1 minus 36x squared? What do you think? No, it would not. That would be negative 1 plus 36x squared. So we cannot turn them around that way. So that's why we have to be careful when we say, does order matter? Yes, the order matters for the terms. The order does not matter for the factors. Okay? Does not matter which one comes first that has the addition or the subtraction, but the terms, their location in the factors matters. So we have to have one of those two answers for this one, number 5. We cannot have 6x plus 1 or 6x minus 1. And that's an easy mistake to make.
All right, so moving on to number 6. Square root of our first term, 6x squared.
Equals 6x.
Yeah.
What times what is 6?
Yeah.
3 times 3 is 6.
No,
not.
2. No, 2.
Okay, is 6 a
I did
perfect
that too.
square?
No.
No, it's not. So we can't use this method of factoring it. So we can just say 6 is not a perfect square.
Oh, because nothing times anything, so it's multiply 2 equals 6. So when that happens, you just say that it's not a perfect square.
So you can't answer it then.
So this way we say it's not factorable this way when we're using or have a difference of squares. This way. Because we have other ways of factoring that we could possibly find out what the factor form of this is, right?
But we're not going to do that today, we're just going to write that.
Yep.
Can it be GCF? Let's explore the ones we know. Can it be GCF?
Yes. Yes.
Okay, what's a common factor they have then?
Oh, no.
Well, is that gonna get us anywhere? Okay. So that method's out the door. What's our other method we know? Cole, what's our other method we could try?
Diamond method.
Diamond method, okay? We're not going to right now, but, so we're not 100% certain this is not factorable, but we know it's not factorable with our difference of 2 squares method, okay?
All right, next part. Super important because I'm sure a lot of students have already tried this before. I'm sure I did once I was in high school. Don't think that you can do the same thing with a sum of 2 squares. So what's a sum?
Addition.
It's the answer you get when you add, right? So what do you think the sum of 2 squares is going to be? It's going to be 1 square plus another square, right? When it was a difference of 2 squares, it was 1 square minus a square. When it's a sum of 2 squares, it's 1 perfect square plus another one. That's the only difference. So, we have an example right there. X squared plus 4 is x squared a perfect square? Is 4 a perfect square?
Yes.
Is there an addition sign in there?
Yes.
So this would be an example of a sum of two squares.
Okay.
Alright, so what a lot of people think that they could just factor this out right away is x plus 2 times x plus 2, or they think x minus 2 times x minus 2 would work.
No.
So you guys FOIL those out and see if you actually get what, or if you actually get x squared plus 4.
Okay, so my question is that right?
That's right.
That's not, which part? This is right. That's wrong.
Well, that's right, but
This is wrong.
wouldn't be able to.
The same thing. Oh,
Square.
Nope.
Alright, so when we FOIL out those first two binomials, x plus 2 and x plus 2, if we FOIL it out, we get x squared, 2x, and 4, right? So when we add any like terms together, what would our final answer be for this one? Ricky?
X squared plus 4x plus 4.
X squared plus 4x plus 4. Is that the same thing as x squared plus 4?
No.
No, it isn't, so that one's out. So we can say a big NO. Next one, we get x squared, negative 2x, negative 2x, and 4. And we combine that with all our like terms. Blaine, what do we get?
X squared minus 4x plus
X squared minus 4x plus 4. Is that the same as x squared plus 4?
No.
No, it isn't, so we can give this one a big NO.
I got a question for you. Would x plus 2 times x minus 2 work then?
Yeah.
Really? Let's see, back to when we were multiplying, special derivative, the binomials, they start with the same thing, they end with the same thing. One has addition, the other has subtraction. What was our shortcut for that?
Oh, wait, no, one, because the original thing has, addition and the answer would have subtraction instead.
Yeah, so what would we get?
We would get 2x minus 4.
You know, we wouldn't have any x's, we'd have x squared
Alright, x squared minus 4.
minus 4, which is, okay?
Alright, so, last question, is x squared plus 4 factorable?
No.
No.
So third one's only factorable.
Sure.
Volkswagen.
What kind of work do they need to show, Mr. Conlon?
Well, let's find out. The work that you need to show is anything that we did for the practice problem. So, you have to find the square root of the first and second terms, and your two binomial answers. Yes, Ricky?
So if we come across any of them that aren't factorable, we just write not factorable.
You say why so?
Alright.
Not
You
factorable.
say not factorable because,
To have addition.
Why? You say that here.
or it's not for a square, or some other reason like that. Okay? Anyone have any questions about anything that we went over today?
Okay.
Alright.
6 minutes of work, we're working right up to the bell. Anybody puts anything away before the bell?